So, when a system gets overloaded, what's our go-to solution? We add more capacity, right? More servers if a website is slow, more people at the checkout line, more lanes for a highway that's always jammed. I mean, it's the simplest, most rational answer to a capacity problem. But what if that very rational answer is exactly what's keeping the problem alive? Yeah, we've all been there, right? A highway just packed bumper to bumper, barely moving. It feels like a pretty basic plumbing issue. You've got too much volume trying to get through too small a pipe. The system is clearly, obviously failing to move traffic the way it's supposed to. So naturally, the solution seems just as simple. If the pipe is too small, you just make it bigger. You widen the highway, add a few more lanes, and create more space for all those cars. It's a logical, direct, and frankly, expensive response to the problem we see. But then, a few years go by, and something really strange happens. The brand new, wider, more expensive highway is just as clogged as the old one was. It's like the system just absorbed our solution and went right back to its old state of failure. How is that even possible? To get our heads around this, let's picture a really simple physical system, a water tank. Think of our highway as this tank, and right now, it's pretty much full. The water level is high, and that high water level, that's our congestion. Now, what's fascinating is that this isn't some new thing we've just discovered. Planners back in the 1930s and 40s saw the exact same pattern with Robert Moses's huge projects in New York. Every single time he'd build a massive new bridge or a parkway to try and ease traffic, it would fill up almost immediately, and it did nothing to relieve the old routes. And this pattern, it's not just about traffic. You start looking for it, and you see it pop up everywhere. You add more road capacity, and sure enough, more cars show up to fill the new space. You buy a bigger hard drive, thinking you'll have space for years, and somehow, it fills right up with data. You finally clear your schedule to get ahead on your work, and poof, it just fills up with new work. It almost feels like some kind of universal law is at play. And this idea perfectly captures a well-known adage called Parkinson's Law. The basic idea here is that demand isn't some fixed, static thing. No, it stretches, it expands to meet whatever supply is available. This is our first real clue that there's some kind of hidden structural force we're not seeing. Okay, let's go back to our water tank. We do the logical thing. We make the tank bigger to handle all that volume. But when we check on it again, the water level is still just as high. We've added all this new capacity, but the congestion is right back where it was. The paradox is just getting deeper. So let's start to peel back the layers here. When we add capacity, more lanes on the road, the generalized cost of using that system, it goes down. And listen, when I say cost, I'm not just talking about money, like tolls or gas. In these big, complex systems, the true cost is made up of a lot of other things. The real cost that's being reduced is measured in time saved, effort you don't have to spend, and just plain inconvenience that's been removed. Think about it. Before, you might have skipped the highway at rush hour because it was just too slow and frustrating. The congestion itself was a cost, and it was suppressing your desire to travel right at that time. So here it is. This is the crucial chain of events. Increasing the capacity lowers the price of using the road. This lower price then awakens this huge reserve of previously hidden or latent demand. These are all the people who used to take the train or travel at odd hours or maybe just didn't make the trip at all. Now they see this new, wider road and think, hey, that's a good option for me. And just like that, consumption shoots up to fill every inch of that new capacity. Back in our water tank analogy, it's as if we just discovered a hidden rule of the game. The moment we made the tank larger, the inlet pipe bringing water into the tank automatically got wider too. The system isn't just sitting there, it's actively responding to the changes we make. But wait, the problem gets even trickier. What if we try to solve it with efficiency instead of just raw capacity? Like more fuel-efficient cars. The expectation is simple. This should reduce how much fuel we all use. But the reality? Well, the reality is often quite different. This is all because of a powerful behavioral feedback loop. Because that super efficient car makes every trip cheaper, what do? We react to that. We drive more, or maybe we drive faster, or we decide to buy a bigger car next time. A big chunk of those expected energy savings is simply taken back by our own rational response to the new efficiency. So let's jump back to our tank and see how this all starts to snowball. Over time, after going through these cycles of adding more and more capacity, our one simple little water tank has become enormous. And now this system is locked in. This enormous tank is now structurally dependent on an equally enormous inlet pipe just to keep it full. And that wide pipe only exists because the tank is there to take all its flow. Development patterns change, people start living farther from work, other alternatives like public transit wither away. The system can no longer shrink. It's trapped. And this brings us to the one question that just reframes this entire thing. We started out by assuming that a congested highway was a system that was failing at its job. But what if we were wrong about what its job was all along? The core structural force we have been watching this whole time, this invisible gravity, it has a name. It's called induced demand. And it's the principle that when you increase the supply of something, like road space, you don't just satisfy the existing demand, you actively create brand new demand that literally wasn't there before. And maybe the most powerful proof of this is what happens when you do the exact opposite. It's a phenomenon called disappearing traffic. When cities have actually removed freeways, like the Embarcadero in San Francisco, the traffic chaos everyone predicted, it just never happened. The traffic didn't all divert to other streets. A huge chunk of it just vanished as people changed their behavior in response to the reduced capacity. So let's go all the way back to our original problem. That system of building wider and wider roads, it did not fail to reduce congestion. No, it succeeded perfectly at generating more traffic. The congestion isn't a bug, it's a feature. It is the mark of its own success. The system, it turns out, is structured not to solve traffic, but to create it. And suddenly, that changes everything.